Hi everybody, Dermot O'Shea here. I'm the host of the Antenna podcast, and today I'm delighted to introduce our next guest, Tim Kelly. Tim, do you want to maybe briefly introduce yourself and give us maybe a timeline of your career in the antenna business and to date?
Sure. Yeah. Tim Kelly. I'm an antenna engineer working over at Amazon. And then as far as my timeline of my career, started off testing antennas outside in upstate New York, or a company called Electrometrics. Kind of just got into antenna test and measurement that way. Worked there for about 3 years and then had the good fortune of getting a job over in San Diego, working for Tower Glass, doing antenna design, cellular, GPS, Wi-Fi, anything that customers needed. Did that for about 7 or 8 years. And then just recently, about 2 years ago, moved up to Seattle and started working on the Amazon Leo program. What's that? Your mic cut out, Dermot.
Sorry, yeah, I was muted. Yeah, that's and full disclosure to the listeners, I got to know Tim from working with him at Tow Glass. We worked on many projects together.
It's
Uh,
true. Yeah.
we had a lot of fun along the way.
A little
And
bit. Yeah, yeah, yeah.
so appreciate you coming on today. So what got you interested in antennas in the first place?
Yeah, I'd say I double majored in physics and electrical engineering in undergrad. So I was kind of looking a little bit into like DSP or other areas of electrical engineering, and really antennas seemed like a good kind of marriage of those two disciplines. I liked doing all the electromagnetics and just like just the beauty of it, of launching electromagnetic waves into air and stuff. A little bit, I had enjoyed that a little bit more. It was a little more pure physics than just digging into like circuit theory or programming. So I ended up getting a job, starting out just a very small, maybe 20, 30 people company doing an antenna test outside. So that mostly, after testing a lot of antennas, kind of got dug into a lot of the design of it and really kind of fell in love with that, being like, wow, you can really, you know, um, make kind of whatever you want. You can make it your own. Uh, it's like you can really dig in there and try as many shapes, concepts, putting different pieces together, puzzle pieces, trying to make antennas work where in form factors where they shouldn't, and these kinds of things. Uh, I just find it really interesting. Good, nice mix of simulation work and getting on the bench and working with your hands. Not didn't really want to do like a software engineering bent where I'm just kind of bent over a computer the rest of my life. I do like being in the lab and doing that kind of thing and getting your hands dirty. So I think it's a good mix, and I really enjoyed it. But yeah, mostly had done some couple different disciplines, and then kind of randomly got a job testing antennas outside. Just kind of dug into it from there.
Fair enough. And did anything like what piqued your interest as a younger kid, like in the engineering area? Like, was there something like project? Was there a hobby that you had, or an activity that you liked that got you into engineering, like building Lego or something like that? Or what was your kind of got you intrigued in the first place?
Oh, for sure. Yeah, my uncle Jack used to get me Lego sets every Christmas, and then we'd sit and do them. And that was the whole thing. We'd freaking spend hours and hours. He'd always get me Lego sets that were for kids way older than I'm supposed to be getting. And then you're sitting there, you're confused, you're a little kid, but he's sitting there working through it, working through the problems, just puzzling away. I really enjoyed doing that, and I'd say what kind of really got me into physics was probably my high school teacher, Mr. Lloyd there, who had just a really great presentation style, really great teaching style, and of, making, kind of the physics come alive, a lot of experiments in class, stuff, lighting stuff on fire and all sorts of cool science experiments. So yeah, I'd say probably attribute it to both Legos as an infant and maybe Mr. Lloyd as a young adolescent, where he really kind of lit the fire there. Where I was like, wow, this is kind of fun stuff, and combine that with a little, I guess, natural ability, and you end up with a nice mix there, a perfect storm to end up doing. Now here I am, 15 years out of school, still doing antennas every single day. So it's been great.
Yeah, and it's great that like I love the fact that you're at Amazon, for example, and we've had other guys go to Apple and Google and Honeywell and places like this because 10, 20 years ago we've been telling people, you know, we're short antenna engineers. The world is short of antenna engineers. People are not doing it in university, and now all the top companies, any companies that do hardware need antenna engineers, and all tech
Sure.
companies are doing hardware of some. They need hardware at some stage. Um, so like, why is that? Why aren't we getting, graduates like you had? Like, it sounds like your physics teacher was awesome. I love the practical teachers that make the subject fun, right? That has a real impact on us. But what happens when we get to university? There seems to be like a lack of electrical engineering students doing antenna work when they're in engineering. Because you, like as you said, it's got great, attributes to it from a job perspective. You get, a lot of variety. You get to solve problems. You get challenged. You're always learning. Like it's a good area to work in, right? So
Yeah.
what's what seems to be what's stopping people in college in your view?
It doesn't seem like antennas, I remember them not being particularly well covered. I think there's a lot of, you do like, electromagnetics, and then, antennas are kind of applied electromagnetics there. But that seems, I remember us at one point being like, all right, well, we don't have enough time. So we're, one of my early electromagnetics courses being like, oh, yeah, we're going to skip antennas because we just don't have enough time or something. I was like, well, that's great. I sure hope I don't end up being an antenna engineer. And, that was before I got into more antenna focused classes. But I think when people are taking like these broad classes that are more a survey of, various electromagnetics and electrical engineering, that I don't know what unless it seems like a lot of folks, unless you specifically go into it as your grad program or your PhD, that just coming out of undergrad and things like that, they mostly just want you to have the ability, I guess, to go into a lot of disciplines. And I feel like antennas, like without being exposed to it, I think a lot of folks see it as black magic, and that don't, and like until you like dig into it and build a couple of designs of your own, you're like, all right, I can think kind of tell what's going on here, what works and what doesn't. I think it's, unless you have an antenna engineer like on staff at that college, I feel like it's hard to really express, the joy of doing antennas, and what you can, do that as a career. And as well, I think a lot of folks see themselves as backseat antenna engineers. They see antenna as like a commodity or something, a capacitor on the board. They're like, well, I can just buy this out of a catalog or anything like that. So
So yeah, that behavior then kind of starts in university because we see that a lot with customers where they kind of the antenna is an afterthought. The antenna is
right.
left at the end. Oh, we can just throw on something, we'll get it off the internet, we'll throw it in there, everything will be fine. And next thing, they have to retrofit or redesign later, which can be very painful and very costly. Um, because we see that right in the marketplace, that attitude is there too, right?
Yeah, definitely is. Yeah, I think it's a lot of folks are just, I'll just, throw something on there and forget about it. And, it says it's going to work on the data sheet. So why wouldn't it work in my product? Right. Yeah, but I think, yeah, when you really dig into doing your own antenna designs, I think that would be a worthwhile part of any, EMAG course is, hey, we're going to sit down and, sit down. I know people don't like copper tape, but I think it's worth doing. Sit down with a bit of coax and copper tape, and hey, let's all make, Wi-Fi antennas for our home routers or something or whatever. I just think it's worth just having that, this is what it is, and getting a little bit of exposure to it, both having the theoretical background and then, maybe one week you're doing the theoretical background, next week you're building the physical prototype.
Mm.
So you're seeing, theory and practice, you know, married in that way. So,
Yeah,
yeah, I think if we just, I think maybe a little bit more antenna labs, like, but yeah, I think it's tough. I think uh, the universities are trying to prepare students so that they can be prepared for any industry, right? And
yeah, fair enough.
the antennas are, yeah, a bit specialized. So I think, yeah, I mean, I'd love to see more antennas in university and courses, and or even, yeah, just even that's in a circuits lab and stuff like that as part of just general circuits and stuff. I think, especially because a lot of these double E's are going to be the ones doing the layouts and doing the boards and selecting components and have more of an appreciation for that as opposed to, hey, this is just a part that goes on my board. They
Mm.
can build, better, I guess, electronics in general. Yeah.
Yeah, well, you see it like, look, there's a big demand for it, right? In military, there's a big demand for it with consumer devices. Look at how many antennas are in your home today. You mightn't
Hmm.
see them, you mightn't really think about them, but the amount of devices we have in our home that have antennas, same in your offices, same in your vehicle. Like everything you do has them. So the amount has like dramatically increased. The complexity is dramatically increased. So I think it's going to, and then that's one of the things we want to cover with this podcast is like a place you can actually get a little bit more education. Um,
Yeah.
but yeah,
Respect the keep out area,
yeah, that's a big bat.
Yeah.
Yeah, to keep
If the
keep
keep out area isn't a suggestion, yeah, for sure. Yeah,
it. It's non-negotiable.
yeah.
But yeah, we often see it. We often see the keep out area completely taken away and
It's
go.
true. Yeah, everyone, they want to negotiate everything, right? Are you sure I can't, what can you give me the dB per millimeter difference if I cover this whole keep out area with copper?
Yeah,
All the
and we
good
just put the
stuff. Yeah.
battery in. The antenna would be a nice holder for the battery.
That's
It's,
right. Yeah.
it's
We
like
love those kind of questions, man. Are you sure you can't design my antenna around my USB? Yeah.
we better not get too deep into this because we have an Irishman on one side and a half Irishman, half Jewish New York on the other side. We've had some very HR non-compliant conversations over the years, so we
That's
better
true. Yeah, yeah.
we better not
We
let
better
them
not
out.
get into those conversations for sure.
Let's not take the bait here, Tim. Let's not take the bait
It's true. It's easy, too easy, man. We're gonna end up getting canceled here.
for sure. Probably have a few more followers though. But
There you go. Yeah.
I was going to say, so yeah, look, I would say we've worked on hundreds of projects together, if not over 1,000. Like, what's been for you personally, like, describe to me, without releasing any company details, but what's been your proudest project, or what, is there something you can point to that you particularly enjoyed as like you well described the challenge that you were faced with, how you overcame that challenge, what was the end result?
Yeah, a lot of some of the like LTE projects we did over the years were really interesting. Trying to get more than one LTE antenna in a small space. That's why we used to say that LTE stands for long-term employment, right?
I love it.
But yeah, so yeah, that was a lot of. I remember we did like a 4x4 and an 8x8 LTE router. That was a lot of fun. So just like trying to get that many antennas all working 700 to 960, 1700 to 6 gig, getting all those frequencies, all those bands, and then having like eight of them. I think four of them were high band only. But yeah, getting all those in a small space and just having that nice like single PCB. Everything was like a copper trace, and it was just me kind of sitting. I believe might have been somewhere around COVID time, so we were like not a lot of folks in the office, and it was just me sitting, with some simulations, LPKF, going back and forth between simulations and LPKF, testing in the chamber, and just trying to get like the best possible performance possible. And I still remember getting that email from someone where they just dropped it in their device and then freaking hooked it up and got the exact same throughput as the previous one, as their previous version, with zero changes. just, they dropped it in, plugged in these 8 antennas to their router, and then did some throughput testing. And it was, yeah, we got it right the first time. And it really, there's nothing more satisfying than spending all that time iterating and iterating. And then you're always, having a little doubt of, oh man, did I miss some sort of property that's going to, screw up one of the responses or something. And, yeah, just, getting that feeling of, a job well done, and the customer was happy about it. So I think it was an interesting like physics problem of trying to get it's only maybe a big size of maybe a laptop screen or something like that. So it was a fun project. And
How much
yeah,
space do you have for the antenna? Like how much?
it was like it's like yeah, I don't know what exactly. It's I don't know, about a sheet of paper, a little bit bigger than a sheet of paper or something like that. Maybe 11 by 11 inches,
Okay.
something like that. And then yeah, I ended up having to do like a bunch of like for the low band, you do like a sequential rotation of the elements, so you get some like polarization diversity to provide to because you can't just only rely on spatial diversity between the antennas. You get a little bit of polarization, pattern diversity, so you can put these antennas a little bit closer together. And
Well, this was a 2 by 2 MIMO antenna then. It wasn't.
it was, I think it was 8 by 8 at the
Oh,
original.
I was wondering.
It was,
I just said
so we had
LTE.
four. At one point, I think we ended up
I wonder how
simplifying
you said it was a sheet of paper. I was there going, hang on a second, this is not.
it.
What kind of antenna? What was challenging about that antenna? Oh, it was 8 by 8 on that sheet. Okay.
Yeah, yeah. So there was four high band only and four low band high band.
Okay.
So
Okay.
there's 8 antennas total, and then 8 of them would be used in the high band, and four of them in only in low band and high band.
Hmm.
So yeah, there was like a bunch of them, and then having all these, doing the isolation of all of them relative to one another, and having an 8 port matrix there of yeah, making sure that we're all that we're going to have enough isolation to really get maximize the throughput there. And it was just a lot of fun of just being able to focus in. Not a lot of folks in the office, just working in the lab, just grinding on this 8 by 8, and then being able to deliver that to a customer, and they drop it in. I think they had already had a antenna from a different manufacturer, and we'd say, well, drop in replacement, plug it in, some cables, and then boom, do the throughput testing, and I think it was exactly the same as the competitor. So it's good times of being like, all right, we were able to do it just a straight up drop in replacement for like an 8 by 8 LTE MIMO router. Yeah.
And yeah, because that time, like just to explain to people, I suppose it was very challenging because they were adding every time we got a project, they were adding the carriers globally. There was new bands announced for it.
Yeah, yeah, exactly. Yeah.
We went down to all the way down to 600 megahertz and all the way
Right.
up to, yeah, very, very, very over. It was happening very fast. And
Yeah, yeah,
so,
LTE band. Well, it was like right around when LTE band 71 was coming out and stuff. Yeah, yeah. So
yeah,
everyone wanted, everything has to go down to 600 now, right? That's no problem for you, right, Tim?
yeah. Just
Yeah.
can you just tweak that there a little bit and come back to me this
Yeah,
afternoon?
just add a little something there. It'll be fine. Yeah, yeah.
But then maybe explain to people how challenging that becomes when you're working on a device that needs carrier certification as well in North
Right,
America,
yeah.
where, as you said, they're measuring throughput for their application, but what they're measuring, the operator's measuring something different, right? That
Yeah, I think that was just like a finger in the wind. Is this going to work at all for our application? But yeah, we had to pass all the TRP and TIS requirements for carrier cert. So we had to be at least, 50% efficiency on the high band, 32% in low band, all these guys, in order to hit, TRP at 20 and 18 with the conductive power at 23. So,
and
um,
when you're hit with those challenges, like what do you draw the knowledge from? Is it like do you have to do more? Are you simulating, or are you researching previous projects that other people have done? Or are you looking at your past work, or are you just simply like trying things out until you see it moving in the right direction?
yeah, yeah. So I think, starting out with like the sequential, rotated antenna elements, and then, kind of iterating on those, and I would noodle a bit in simulation, but I do think you can also derive a lot of like intuitive understanding of antennas on the bench. So like uh, getting a sense of, all right, I can look at the surface currents in simulation. I can get a sense of how the currents evolve there. I can also go on the bench and sit with like a chopstick and a piece of copper tape, right? And I'm running the chopstick over high current areas that I've identified in simulation. And, I think it's part of the creative process is just sitting there with an X-Acto and I can try this shape, right? And I don't have to wait for my meshing to then, complete all over again. And you can just kind of iterate through a lot of different design ideas on the bench. So, well, I think it's hard to, I guess, exactly explain what the creative process, but a lot of staring at it, then trying to see what kind of shapes we can work out, and then essentially, you can go into the literature and look at those, but I try not to draw too much from that because then you end up with some like cryptomnesia or something like the false sense of generating your own idea. So, yeah, a lot of kind of trying out different things and just being like, hey, maybe we can do this, and hey, maybe we can do this, and uh, even trying to take portions of other antenna designs that maybe not traditionally used for LTE, and hey, can we implement something that's from a different application and then scale that up or something and apply that here. So just yeah, just keep trying new stuff every single day. Freaking coming into the lab, say, hey, look, we're gonna cook up a different antenna design. Maybe it'll work, maybe it won't work. But I think it was a nice, I guess, time in my life where I was having like the ability to kind of do that, where it's like, uh, we always had a mad rush of projects when we were doing there, but I think it was like around that time, it was like, we kind of need you to focus in on this one, like just kind of iterate through there. So
Yeah,
I do think, yeah, it's a bit of a creative process. I try to keep all the tools in the toolbox. Simulation's a good tool in the toolbox. It's not the only tool. Getting on the bench and cutting copper and messing around, I think, is also a nice creative output. And you can take those, copper tape designs, you build them back up in simulation. You make sure that you weren't just chasing some bad solder joint or anything like that. But
very
yeah, try to do a mix of both, and then just uh, mix and match, right? Just like Legos, huh?
yeah. Oh, there's a lot of analogies like with Lego. I've always wanted antenna production to be more like Lego in terms of like, can we build blocks of antennas that then a customer can go, right, well, I don't need the Wi-Fi, or I'd like to add, Bluetooth. Okay, leave off and
Sure,
build.
yeah, yeah.
But it's harder in practice than theory to implement it all. But that's my dream someday, to have a little
Yeah, yeah, yeah. It would be
assembly.
nice. It would be a component you could just drop on the board, huh?
Shit. Okay. So look, final few minutes here, Tim. Give us a deep dive into. Well, you've already talked good there about a technical topic, but maybe take something purely antenna related, that you think you can educate our audience on, and the floor is yours to discuss any topic you like
Any topic I like. Wow, I should have.
as it relates to antennas.
um, for sure. Yeah, yeah. Yeah, I think it's, I suppose, interesting in terms of when you talk about like noise and, the antenna is only one part of the equation. And we're talking about, TRP and TIS, but definitely on the TIS side of just having this huge, but just like it's not as simple as, a transmitted power and an average gain, is that you have your coupling to you have like, I guess, the most authentic antenna experience, I feel like, in receive mode, is that you're coupling to your entire device, right? So you have noise generators or potential noise sources that can, come into your own receive band there. And I guess what I find kind of interesting is how those noise generators have certain, noise profiles, and how those profiles could be essentially either manipulated, or my antenna orientation could be manipulated to try and, minimize that coupling. I know it's, traditionally you just shield aggressors and then say, hey, I have noise sources from X, Y, and Z. But I also think it's just kind of fun to, hey, if I could spin my, antenna around so that, it happens that I'm assuming that, each one of those orientations has, equally good antenna response. Can I kind of spin my antenna around to minimize the coupling between like that specific field distribution of the aggressor and the field distribution of my antenna and things like that. So I think there's a couple, like, I know it's just kind of interesting of like, oh, does the orientation of those, let's say I have a noisy power supply or something, can I spin that power supply so that those field distributions are, coupling less into the antennas? And, if I have this 45-degree angle, all of a sudden, the dipole moment of that is not so much aligned with the exact field distribution of my antenna. So I think there's kind of interesting tricks there. And then, I think that's kind of like just having it as like that holistic environment of, quantifying the noise in that way, and then like producing an antenna that's, let's say, not obviously it's not going to be immune, but I guess somewhat resistant in that way, is that I've kind of messed with my product design environment in that sense, that I can, let's say if I had the ability to spin a power supply 5 degrees at a time, or spin the antenna 5 degrees at a time, could I find a mix of angles where that aggressor victim relationship is kind of minimized? So I think those are kind of an interesting thing there. Like how do we, create, effective low-cost antennas without becoming really, really ground plane dependent and stuff, and, picking up a bunch of noise off the ground? How do we choke off those currents? All those kind of like interesting things where it's not just, I think it's easy to just, all right, drive up efficiency, drive up efficiency. Like we need more efficiency, we need more. And then you end up in this spot. We used to always run into that problem, Dermot, of, I fixed TRP, why did TIS get worse, right? So
Yeah.
I think really coming in to the antenna design from that holistic approach and being like, no, like we need to quantify all the aggressors and like have, a matrix of relationships between these things. And not just, we're going to put a bunch of stuff on a board and, fingers crossed, we'll pass TIS, right? Or we'll put revisions for shield tracks and stuff like that. But I
Yeah.
just think it's just kind of an interesting ability, or like, is there any ability to do those things outside of just traditional like shielding exercises?
Yeah. No, that's great. Thanks, Tim. Yeah, no, hope is definitely not a strategy when it comes to antenna implementation.
That's true. Yeah, yeah, it sure isn't. Yeah, yeah. Usually, you hope your way into a early grave there. Huh?
Yeah, no, we've seen that. We see that a lot. Like you'll never get the perfect antenna, so sometimes either. But like you gotta get something that works well, good enough for your own application, meets the price point, but also gets you through certification, right? So it's
Hmm.
all, as you said earlier on, the negotiation between where probably marketing and sales teams want the device as small as possible.
It's
There's
true.
two,
Yeah, yeah,
but like engineering teams usually want it to perform as well as possible. So you're trying to strike the right balance to keep everyone. I feel like when you come for an antenna, you need to leave mildly kind of unhappy. So like you know what I mean, not
yeah, yeah. It's
totally.
a good design when everyone's unhappy,
Yeah, yeah, yeah. You're not going to get everything you want, but like, is it, hopefully in 3 years' time you'll be there. That was a great result at the end of the day because our device
right.
works awesome, and we've sold hundreds of thousands of them. That's what we're aiming to achieve with customers.
Yeah, that's the idea. Yeah, yeah, for
Oh,
sure. So,
okay. Well, we miss you, Tim, especially fantasy football. You used to run that for us, and
I
now
know the
nobody
commissioner is out of
anymore.
commission here.
Yeah,
Yeah.
and we can't give you a hard time about the Giants anymore, so we miss that as well.
That's true. That's true. Well, I think the whole world can give me a hard time about the Giants.
Ah, yeah. But yeah, well, look, great conversation, Tim. Tim, we
Yeah,
really
definitely. Yeah,
appreciate
yeah.
you, and thanks for coming on the Antenna Podcast. You can look up Tim Kelly on LinkedIn. He works at Amazon now, and he's based in the the state of or the great state of Washington
That's correct. Yeah.
these days. So you'll find him on LinkedIn, probably the best way to connect with him. He loves to talk about antennas, and we'll talk to you about them all day long if he gets the chance. But
That's true. It's true. Well,
yeah,
cheers. Thanks for having me, Dermot. Appreciate it.
okay. Thanks, Tim. Talk to you again soon. Bye.
Sounds good. Have a good one.